Okay, so I'm going to give you an example of a chemical equation, and we're going to walk through together step by step how to figure out if that equation is balanced. So the first one I have is NO2 plus H2O yields HNO3 plus NO. Garrett, no problem. Just grab your notebook. We haven't done much. We were just chatting at first. So the first thing you have to remember is that in a chemical equation, the products and the reactants have to be equal. We have to have a conservation of mass. So everything on the product side, no, reactants, sorry, has to be equivalent to the products. They have to be the same. So what we need to figure out is what kind of atoms and how many do we have on the reactant side, and how many do we have on the product side. So the first thing you have to do is identify what elements we're working with. So we have an N, an O, and an H, and an O. So we have nitrogen, oxygen, and hydrogen on this side. And hopefully we have the same on the other. We have hydrogen here, nitrogen and oxygen, same, just in a different order. That's fine. So then we've got to count how many of each type we have. So on this reactant side, I have 1 nitrogen. In this molecule, I have 2 oxygens, and in water, I have 1. So that's 2 and 1. That's going to give us 3. And then in hydrogens, I have 2 hydrogens here in the water. So on the product side, I've got 1 hydrogen here. I've got a nitrogen here and a nitrogen here. So that gives me 2 nitrogens. And for the oxygens, I have 3 oxygens in this molecule and 1 oxygen in this molecule. 3 plus 1 is 4. So in total, I have 6. And here in total, I have 7. That is not equal. So that is not equal. So that is unbalanced. That equation is not balanced. That is not going to give us the reaction that we see in that chemical reaction. So far, are you following me? All right, second example. 8CO plus 17H2 yields C8H18 plus 8H2O. Step 1, Figure out what types of atoms we're working with. C, O, H, C, H, H, O. Same type. Good start. Next thing, you need to count using our skills we used when we were counting atoms in all of our molecules and figure out how many of each of these we have. So I'm going to give you a chance to work a little bit independently, and I'm going to poll you to tell me whether it's balanced or unbalanced. So give me just a second. Doing something weird. So once you think you know the answer, answer my poll question, please. Is my screen still sharing? Okay. The green box that's usually around the stuff you're sharing isn't there, so I was just double checking. All right. Most people have voted, but not everybody. It's been a minute and a half, so I'm going to go ahead and close the poll. We ended up about 50-50. So that's probably not a good sign. Let's work on it together and see if we can come to a little more agreement. So on the reactant side, carbon, we have 8 molecules of carbon monoxide, each have this imaginary little number 1 here. So I should have 8 carbons here. For oxygen, I also have 8 oxygens. And for hydrogen, I have 2 hydrogens in each molecule and 17 molecules. So that gives me 34 hydrogens. Big maths. All right. On the product side, I have 8 carbons in the first molecule, 18 hydrogens, but I have more hydrogens over here. So I have 16 more hydrogens in this molecule. So that gives me 34. And then I have 8 times that imaginary number 1 there, and I have 8 oxygens. So I have 8, 8, and 34. So that is balanced. Those of you who missed on the poll, do you see where you made your mistake? Does anybody have a question about how I got any of these numbers? All right, I'm gonna move. Thought there was only one. Well, 1, 8 is close. I add incorrectly and multiply. These are kind of big numbers. So let's do one more. Let's do C2H2 plus 2 O2s yields carbon dioxide and water. Oops, I'm sorry guys, there's supposed to be a 2 here. I apologize. 2 carbon dioxides and a water. So I'm gonna let you try to do that one on your own from the start. And I'll put our poll up there again. All right, same amount of time. Much more convinced, you guys, not 50-50, so that's good. Let's double check this one really quick together. Those of you who didn't finish, keep working, that's okay. I just wanna make sure we don't run out of time in class. So I have 2 carbons here, 2 hydrogens here, and in my oxygens, I have 2 times 2 is 4. On this side, I have 2 carbons here. I have 4 oxygens here. I have 2 hydrogens here, but I got an extra O here. So I got to add that, which gives me 5. So I have 2 carbons, 2 hydrogens, but my oxygens are 4 and 5. So that is not equal, that's unbalanced. So these steps where you identify the elements, you count the number of each kind that you have, and then determine if they are balanced or unbalanced, is what you're going to be doing in today's